welcome back. Okay, now before we carry on with static 2 today, which is mainly on application, I want us to do a quick recap. Okay, so over here you can see that I have written 2 main points. Okay, first we look at this bracket followed by the remaining brackets. Okay, now the first thing on top is charging by friction or rubbing. Okay, depending on if you are actually reading a textbook, charging by friction is a quite common term used in the textbook. Now when you talk about charging by rubbing or friction, we want to talk about this thing called contact. Okay, so the idea is contact. Okay, so if you are playing with two insulators, in order to charge, you need to bring them into contact and you need to rub them because you need to produce friction. Okay, and this is there will then be a transfer of charge. Okay, it's not about attraction or repulsion, it's about rubbing, and when you rub, there's actually a transfer of charge. Now then we talk about induction, okay, which is talking about how we can configure the charge, how we can alter the charge configuration without contact. Okay, so over here I write here doesn't require contact. Okay, so in induction we are mainly talking about repulsion and attraction, and I hope you remember this diagram. Okay, if you're not, please return back to static 1 to look at what's happening. Now when I bring the positive rod here, okay, now what will happen is that the negative charges here will be attracted to it, while the positive charges here will be repelled by it, right? Okay, so yeah, basically that's the idea behind induction. Okay, so these are repelled and these are attracted. Now so whenever you talk about induction, please talk about repulsion and attraction. Whenever you talk about charging by friction, please talk about a transfer of charge due to rubbing or friction. Okay, so after we are clear on that, then with this we can actually go to the applications today. Now in this video I'm going to talk about 6 main applications of electrostatic. Of course there are more. If you are interested, you can go find out, because the principle behind it is pretty easy. Okay, it's either induction or it's either charging by rubbing or friction. Okay, so it's either one or the other. Now very quickly then we will talk about the lightning conductor. The animation is down at the link below, so check the link for animation if you need to know how the lightning conductor works. This animation I played it in class previously, but some of y'all may not be clear, so please watch it if you are not clear. Okay, okay, let's then continue with using the PRO method. We'll figure out how the lightning conductor actually works, but before that, as you see at the bottom right hand corner, it's 10:39 and the bell is going to ring anytime, so I'll pause. Let's come back. Okay, so for P, right, what is the principle behind the working of a lightning conductor? Now the lightning conductor works because of induction. Now you see the cloud and the conductor, they are never in contact, but yet however they are able to change the charge configuration of one another. Okay, so that is the idea behind it. Now for the R, right, relating induction to this case, right, you will talk about the attraction and repulsion of charges. Okay, now of course the detailed answer is in the PowerPoint slide. Okay, but it's basically the attraction and repulsion of charges between 3 parties. So who are the 3 parties? Between the in this case the negative cloud, the positive rod, and perhaps the positive the negative air. Okay, so basically, right, when you talk about lightning conductor, there are 3 parties involved: air, the rod itself, and of course the cloud. Now finally, what is then the outcome? The outcome is a gradual discharge. Okay, so I think I wrote here gradually discharge ionized cloud. Okay, so this is basically the outcome. This is the outcome actually tells you the purpose, and I think knowing the purpose makes you clearer how to answer questions. Okay, so if you understand how it works, then yeah, we can explain. Please try this question, try it yourself. Explain how lightning conductor reduces the occurrence of charge accumulation basically is what we went through. Okay, so if I ever write a good answer, yeah, please do. At the end of the day, at the end of the day, I want to collect this, yes, and so that I can mark all your try yourself answers. Okay, now for the Graaff Generator, okay, now this thing, it works by let's talk about how it works first. Okay, so if you are not sure, okay, this thing, it actually shows you how charges discharge itself. Okay, so you see the ground wire here. Okay, so this is to bring charges to and fro. Okay, depending on what kind of model this is. Apparently, this is a positively charged model. Okay, so the ground will bring the negative charge from the sphere, if any, into the ground. Okay, now the second thing that you want to know is that you see there's a metal comb here, and there's a metal comb here. Okay, now the metal comb, is it in contact? So if it is, then you know the principle is charging by friction, but in this case it is not. It is pointed at top to allow charge to spread to the metal dome. Okay, so remember how charge accumulates. So for metal comb may look like this. Now there are a lot of sharp edges on the metal comb, so charge may want to accumulate here, so which is good. Okay, and then with this, it actually can direct charges into one singular point, so that charge can be directed down. Okay, so that's how the metal comb actually works, to spread out the charges to the metal sphere in this manner. Okay, so for the principle behind this, it will be induction also. Now the relatedness of this question then is how charge are being distributed. So charge are being attracted / repelled, okay, depending on what charges you are talking about, and who are the parties involved. The parties involved are the conducting sphere as well as the comb. Okay, and the outcome is, of course, this. This is the outcome. Alright, so that's how this Graaff Generator works. Okay, so yeah, explain why observer. Now note that the observer touches, but there's no rubbing, so this is also by induction, just to help you all a bit. Okay, if it is not grounded, then ask yourself, where will the electrons go? Okay, the idea of grounding is so that you are connected to an infinite amount source of electron. So if you want to give it back to the ground or take from the ground, you can do that if you are grounded. Okay, so the next one is electrostatic spray. Now the spray, if you realize the negative charges here, they are not per se rubbing against the positive plate, but yet the positive the negatively charged spray paint can still be layered onto the positive plate. So once again, this is induction, and the relatedness is attraction between the positive plate and the negatively charged paint drops. Okay, so basically it's just two parties here, paint drops and plate. Okay, so if you want to know more on how electrostatic spraying works, same, you can go down to the link. I showed this video in class, so I think it's quite easy to understand. Okay, of course the first thing then you have to do, right, is you need to charge this plate. Okay, and same thing, of course, you have to charge the pin, and you must make sure that they are of the opposite charge. Then of course the outcome is then painted lah. Yeah. Okay, and one of the reasons why we want to use spray painting is because of this. It can be much faster. Okay, now try the questions yourself again, and now we go to the dust chamber. Now the dust chamber if you realize also, the gases are coming up in this manner. Okay, so take some time to read 1, 2 and 3. Actually the answer is already here. So smoke particles will pick up a negative charge from this plate, from the blue color plate, so that the smoke particles are now negative. Now when the smoke particles are being pick up a negative charge in this manner, these red color plates, right, these red color plates, they are positively charged. Okay, so these two, they are positively charged. Now what happens then is, of course, attraction will happen, and when attraction happens, okay, the smoke particles will come to the red plate. Now because of the mass of the red plate, okay, I mean the mass of the smoke particles, okay, it is easy to knock them out from this system, and they'll be collected here, these boxes. Okay, so what happens is that for so-called a life cycle, or like a cycle of a smoke particle, the smoke particle will be here, comes up here, it will be charged. So let's draw it in blue. So once it's charged, it will be attracted to the plate. Now when it's attracted to the plate, you will knock the plate out, knock the smoke particles out, so the smoke particles will drop and be collected in this place. Okay, so this is the final destination of the smoke particles. Okay, so you don't have to write this, okay, but if you have written, then it's fine. Okay, now for the P, now the smoke particles, when they come to the negatively charged metal grid, but are they in contact? Not really. Okay, it's more of there's no permanent rubbing also. Okay, so you may want to call it induction. Okay, or you can just say that the smoke particles in this case are made negatively charged by the metal grid. Okay, and the relatedness, which I just explained, so just follow step 1 to 2, then to 3, and finally to the knock part. Okay, and the outcome is this will then be the outcome. The outcome is that you can actually separate the gas without the smoke particles. Now this is easy, okay, because if let's say you are sending into a gas chamber, you don't want the smoke particles to destroy that chamber, so you want to remove the smoke from it. Okay, so now before we go on to number 5, maybe let me skip number 5 because it's of a different concept, but let me go to number 6. Now for number 6, right, what happens in this, yeah, if you want to, I might have a link below, okay, so check out the link for gold leaf electroscope. I hope I can find one animation, a nice one for it. Okay, now basically what happens to it is, this is a gold leaf. Now the gold leaf is usually flat, okay, so it's usually closed in this manner. So actually it's made of 2 leaves now. Okay, so you have 1 leaf here and another leaf here. Now what happens is it may either repel or attract depending on the charges. Now, so basically when you have okay, so this is the outcome. Okay, so basically the purpose of this, right, is to check what is my rod positively charged or negatively charged, or is my rod even charged. Okay, so when I place it here, right, okay, now this cap, right, will be this entire thing is one system, you see. So what will happen is that because at first this entire thing is neutral, okay, let me write in green, okay, because this entire thing is neutral at first, okay, but because of this positively charged rod, now the negative are going to come here, and when the negative are here, that means everything here is plus, right? Now what do you think will happen to the blue and the black? Then they will actually start to repel. Now when they repel, then what you get is something like this, because there's a plus here and there's also a plus here, because the negative charges are on top at the cap. Okay, so this is basically what how you know the presence of charge exists on So the question the rod might be asking is, am I charged? And the answer is yes. Okay, so you realize that charge configuration is affected without any contact, so this is again induction. Okay, and what is being involved here is the rod, the cap, and the go leaf. So basically the go leaf actually repels since they are of the same charge. Okay, and yes, and this is the idea of a go leaf electroscope. Alright, let's go to the last one. Now, this is about discharging static on car, and you realize that this thing here is in contact with the road. Now what happens is that for a wheel, right, as it continues turning, right, okay, as it continues turning, okay, a few times, there is contact with the road, and when there is contact with the road, there's not only so, it is constantly rubbing against the road, right? Now with this, actually what you get is an accumulation of charges. You are transferring charge from one place to another, okay, basically from the road to the tire. Okay, so it's between the road and tire. So in order to, the principle behind this, right, then is charging by rubbing or friction. Okay, now what you want to do is to discharge the car so that the driver inside the car won't feel a static electric shock. Okay, so actually it's discharging by rubbing or friction. The idea why the car can accumulate charge in the first place is because it's being charged by rubbing. So what you want to do eventually is to discharge it. Okay, so for this PRO is a bit special. You may want to know that I'm actually talking about how cars are charged. Okay, because we need to understand this first before we talk about discharge. So there's charging by rubbing or friction, and it's between the road and the tire. So the relatedness for this is between the road and tire. So when the tire rubs against the ground, okay, it actually accumulates electrons on it. And because the tire and the car are one system, the entire car will be charged at the end. So car and tire is one system. Sorry, are one system. So they will be charged. So how do we discharge a car then? You realize that in order to discharge a conductor, and you know that car body is made of metal, right? If you refer back to static one, all you have to do is to ground it. Okay, so there comes this thing called there's this name for this wire. Okay, it's called the grounding wire or something. Okay, so basically it connects the car body, which is a metal, to ground. In this case, okay, the electrons will flow from car to ground, and this is how you actually discharge it. Now modern day tires, they are conductor on its own. Okay, so when charge are being accumulated on the tire, they actually discharge at the same time. Okay, so yeah, these are the main 6 applications. Of these 6 applications, you realize that lightning conductor is induction, 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 and this is actually by rubbing. Okay, so yeah, that's it for this video. Do try the question, and then perhaps you all can submit, and then I can mark for you. Okay, so I'll end the video here. Thanks for watching. Bye.